Okay, chapter 17, we're going to look at what are often called autoencoders or GANs, which are adversary auto-encoding networks. The idea here is that often it's challenging to find data sets we can train things on, but there's lots of data out there. So one thing we can do is we can train networks to regenerate the same data we're getting and that's what are often called auto-encoders. So auto means to repeat what you were given back to you. Um, and encode it in one way or other. And idea is that you can train these networks to take an image, distill it into an encoding, and then regenerate an image. And once you have that, you can create other generators, and you can actually generate other types of images from these images. Now, we're mainly going to look at images today in GANs, but it can be used for other networks and other data ideas. So the idea here is to take some input, like maybe a chess screen, encode it into a smaller size encoding, and then create the output. So maybe you are given this image, and then from this image you can encode, if you're a human, you would just encode what pieces are in what locations, not every little pixel here. So you could have a smaller encoding, and then from that encoding you could regenerate the image here. But also, if you had this encoding, you could regenerate the image and maybe draw it out as a fancier three-dimensional chess screen, on a marble chess checkerboard top and things like that. Generate a different output. So I'm going to skip over the section on PCAs. So this is a way of doing principal component analysis and reducing the number of variables that represent data. We talked about standard PCA, and then this is used similarly. But here we're going to look at this. We're going to feed this into some images into this version, and they're going to have 784 pixels. And then we're going to train the network to go down to 30 units, so from almost 800 down to 30 units, and have an encoding of an image that's only 30 features or 30 units big, and then be able to recreate that image from that. And we're going to look at the fashion minced data set here and reconstruct that. So can you take one of these pictures, condense it, down to just 30 features, and then recreate that image in some ways. So let's jump into our notebook here. So again, importing libraries and then loading the minced data set here. And then we also define a method to plot multiple images from this data set that we'll be using. And here's our generative adversarial network. And so we're taking our input image, flattening it down, and here we're not even using convolutional neural networks. No image processing. We'll do that in a sec, but we're just using encoding it into 100 units and 150 units, and then this is the generate. Sorry, this is the discriminator, the encoding. We flatten our image. We then convert that to 150 units down to 100 units, and then our output here. And then we do the reverse to generate that. We take those 100 units, go to 150, and then go to 28 here. And then we train our images here for this. Now, sometimes with these systems, because of the way they're set up, we have to run our own little training systems still. But here's showing how we're trying to regenerate these images. So we're feeding it an image and having it try to encode it and then regenerate that same image. And so it gets some of the basic features. And again, this is just under one epoch, and if we keep training it, it should get better at learning how to train or how to memorize these systems. So I think this is where it's supposed to be going for 50 epochs, but I'm only at 17 now here, but it should be working on more for this. But again, this is just a simple network. It's not going to actually do very well because our network is not finding a very good encoding for this. So we're going to look at using convolutional neural networks to do a little different encoding of this. Let me jump back into the book now. Okay, so we're talking about the fashion minced, and again, the idea is that these images can be kind of mapped into different spaces, and we can see there are different features that some of these images have, and if we can extract those features, we can then recreate a lot of these images nicely. And so one of the goals of this is using pre-trained autoencoders to do other things. So you might start with some, again, autoencoder that's, we input an image, we go through these hidden units, we find some concise encoding for that image, and then we output and try to recreate that same image. And what's that nice about that, we can train that. We can just give it an image and have it try to produce that same output. But once we've got it doing that, we can then chop off these top couple layers and just use the input, the hidden layers here, and then copying the parameters and the pre-trained model here. And then so now we have a pre-trained model that, given an image, creates a concise, feature-rich kind of encoding of that image in just a couple parameters. And then we can use that, and we can train that on some output to output whatever we want. And this training will be much faster because this is already done for us here. This talks a little bit about setting some of this up and then training them in different ways and trying to get this internal stack set up, copying the parameters over to the new phase of this. And then we get in these convolutional autoencoders. Again, all that means is we're using convolutional layers instead of just hidden layers in here, and some like max pooling and stuff like this. So again, here we're going to start with our 28 by 28 image. It's only one layer deep. And then we're going to create 16 3 by 3 feature vectors out of this, and now we'll have 16 layers. And then we're going to shrink it in size to half the size, and then double the number of features, shrink it in size to half a size again, and then double the number of features here. And so these features should be extracting some very interesting features from this model here. And then when we can then have it regenerate that image if we want for this. So here's this is the encoder and this is the decoder. We'll do basically the opposite of this, and then returning and generating the image from this, and then we'll stack the encoder and the encoder and the decoder together. So that's what we're doing here. We're defining a simple convolutional neural network for generating this, and another one for, here they're calling it the generator and the discriminator rather than the encoder and decoder for this, but they're setting it up to do that. And then this type of network will hopefully generate better networks for us. Now, I mentioned that you're using this term generator and discriminator, and that'll get into this adversarial network soon, and we'll talk about this. So a typical autoencoder typical autoencoder will be set up this way, where we'll have an encoder which will just take an image and encode it into some internal limit size representation, and then a decoder which will decode that representation out here. Now, so far we've been talking about images, but we can also use this in sequences. So we can be like taking sentences and have autoencoders for sentences. So this is a recurrent neural network learning using long short-term memory nodes here, and then we have an encoder and a decoder set up. So you can also set up these features. We're not going to look at that too much right now. So here's an example of a denoising autoencoder where we'll introduce some noise into our inputs and then see if we can generate the output. So we have noise out, some noise in here and generate the output. So if we have noisy input data images, we can hopefully learn to train. So then we can provide any input and have it train the outputs for this. So this shows, creates these noisy versions of these images, and then the network should try to recreate the original image from this noisy image for us. I'm still training over here. I wanted to check how that was doing. Okay, and I'm going to skip over this sparse stuff for now and get down to we want to get to a new version of these autoencoders called adversarial autoencoders. And so again, this talks about generating this mince data with different formats here. Okay, let's talk about generative adversarial neural networks. Again, these are relatively new, about 5 years old. And so rather than an encoder and a decoder, we talk about having a generator and a discriminator here. And a generator is basically a kind of an encoder decoder combination that will generate, given some input, will generate an image or a sequence words or something like that. So this is kind of an encoder decoder together, but we usually just talk about the decoder part of this that we're trying to train. And then we have a separate network called the discriminator, and the discriminator will look at the image that the network created and the real an original image, and then it will try to determine which is which one was fake and which one was real. So the discriminator is a little network that sits on top of this generator and will try to determine which one is better. And initially it will be quite obvious. This one will be blurry and this one won't. It'll be kind of like looking at, if we look at this image and you look at the top image and the bottom image, it's really easy to tell what one is bad and which one is good here. So originally then the generator is not going to be very good, and the discriminator will have a really easy job. But as the generator gets better at generating these fake versions or recreating the original versions, the discriminator has to learn more and more how to do this. And the generator and the discriminator have a kind of a little competition back and forth. The generator keeps improving, and so the discriminator keeps learning better and better ways. And it forces, and then together this helps improve the generator version of this. So it's just a new way of kind of training your generator here. So this talks a little bit about this and sets things up. And so that's why in the model I'm training right over here now, we're talking about this being a discriminator and a generator here. So our generator generates images, so we've got some input going in, and then we're doing some different layers on this, including some convolutional transposition layers to generate an encoding of a resulting image, and then our discriminator is taking that result and then trying to determine just one thing: is this the original, which one or not for this. And so which image of two images is kind of the original, and we set these up and train them. So this talks a little bit about how these networks are set up and run, and then the training mechanism that has to be in place to do this. Again, a lot of this stuff is relatively new, and the training is somewhat specialized, so you have to often write your own little training loop in here, especially if you're adding noise and stuff like this. And so it's not too complicated, but again, it's a little more complicated than just saying fit, which is what we often call. So you basically are creating your own little fit function here. And again, in future versions of these networks, we'll see this sort of version functionality built into Keras and other language systems like this. So. So here's some examples of images generated after just one epoch of training, and again, they're not very good. And they can improve. Now, there are some issues with training GANs, these GANs that have been discovered, as far as sometimes the discriminator gets too big, too good, too fast. Sometimes the generator has trouble, and so there's some issues on how to balance this training and using slightly different, balance as far as training these systems go. And there's been some good progress on how that's been. So here's a deep convolutional GAN. This is a more commonly used GAN that's out there, where the generator is a number of convolutional layers, and the discriminator might be something like that also, that's trying to look at, analyze an image in more detail and produce an output for that. So there's been some really interesting stuff done with autoencoders and generative networks and GANs. Here's one example. This paper had a bunch of images of men and women with or without glasses here, and then it created an internal representation of these images. And so with this internal representation, we could add them up, and so this, and then generate images from that. So this is a combination, an average kind of man with glasses image. This is a combination man without glasses, and this is a combination female without glasses image. And then you can do things like take these feature vectors and say, okay, take a man with glasses average figure, subtract the man with, without glasses, and add in a woman's features, and this is what you get. You get a woman with glasses, and these are just 9 different versions of the network generating images from that. So we've seen a number of progress in recent years with GANs, growing them. Again, sometimes it's hard to train a GAN with many levels, so they've talked about building it up a couple layers at a time and training different discriminators as you go with this. And then Style GAN, which is a interesting paper that's just a couple years old, talks about feeding in images into a network that tries to do feature extraction with fully connected layers here, and then feeding that into that, so it finds some encoding of the image, and then feeds that encoding into a generative convolutional network, and each layer gets to see this encoding of the image here. And then this is set up in a certain way where, again, we're trying to create an image here with just some constant noise as a background feeding into this image, which again goes through a couple convolutional layers often, and then is increased in size and in convolution. So this is a generative kind of a reverse version of a CNN, where each time the image is getting bigger and bigger, and we're getting less and less feature layers until we finally produce an image out the back. And then we have, again, some noise being fed into each level here. And then in fact, this network, this generative network, is actually broken into 2 parts to try to manage how the style is generated for that. But that can try to create images of different styles. And so you'll see this kind of method used in a lot of GANs. So your book doesn't go into some of the more recent stuff, so just a couple examples of where I've seen this information. So just recently, I've been colorizing some old family history images, and I've used this image colorization API. This is from deepai.org, and it's a network that's been trained in with to colorize old family photos and stuff like that. So it's been trained on black and white and color versions of photos, and so it was trained to do this so that now if you feed a black and white image, it will encode that and then decode that into a colorized version of that photo in different ways. So again, that's using a deep neural network that's been trained to do this colorization. It does an okay job. There's another article I'll post a link to uh, in our notebook. It's just 8 examples of these generative adversarial neural networks (GANs) and how they've been set up. So it talks about the same paper that the textbooks looks at as far as human faces and adding or removing glasses, but just talks about using these GANs to actually generate unique human faces. So you can just have it take some random noise and generate, after looking at lots of faces, generate unique faces that aren't actually of people but are computer generated faces or scenes. You can have it create scenes. So this is just an example starting from 2014 to 2017, how quickly these have progressed with how quickly they could generate faces for this. Or again, realistic photos or cartoon characters for these things. Talks about image to image translation or conversion. So taking a couple images and generating an image from that. So taking the style from one image and then an original image and then copying that in different ways. And this is a really interesting version. If you haven't seen this, is training, taking images and training it to do it in different painting styles. So you might feed it in different pictures and then have it generated in a different style, like a classical artist style, or again, train it to change animal types here, or change different seasons for this. So you can train it to do different things. Geez, last time I was at a conference, they had a live webcam set up with this system, and you could, it was doing it a live video, so you could stand there and look at it, and then you could pick any of a classical set of art images, and it would translate live your picture, and you could look like you're pixelated, or any of these, look like your art techniques that are out there, and does a really good job at that. So. Other examples of this sort of stuff, interesting version is this text to image translation. So now we're trying to give it a sentence and then have the computer draw some images based on that sentence for it. So again, we're just having it given a sentence and having looked at lots of images, can it recreate an image based on that textual image in some ways. So, and again, these aren't like grabbing photos or identifying photos. It is actually trying to regenerate an image from scratch based just on the description of it for this. And again, we're seeing other examples of high resolution or generating different things. Here's an example of face frontal view generation. So given a side view, can train a neural network to generate the front view given a side view of a person. Generate unique human poses. So if we have these dots that like a person is tracking, so often you'll be wearing these reflective dots and sit or stand in different poses, and then we're given 2 pictures of a person. The network then tries to generate a image of this person in this pose here. So we have this person in this pose. in different ways. So, and again, pixelizing or creating emojis from images, photo editing, changing haircuts. Sorry, my cat just walked in here and is being needing a little attention. So okay. So again, there's lots of stuff being done with GANs in different ways, and some of this is just adding to resolutions or removing things, face aging. There's lots of interesting techniques, so you can kind of look through this article and kind of see, but hopefully you get an idea of how this is now working. We are now taking these networks here, setting them up. We're training them. We're having training the network to create an internal representation, and then from that internal representation, training it to generate the figure itself. And then we're often training a discriminator to try to tell the difference between the generated image and the original image. And then we can then train the network not just to reproduce the original image, but reproduce different kinds of images. So you can see here, this network is trying to generate these different things from the fashion minced set in different ways. Training can be slow sometimes with these GANs, but again, we can still get these things, even if it just takes a couple days to train this network. It then can be used on lots of different images and stuff. So hopefully you will appreciate this and continue finishing up your final project this week.